go. dy dx is equal to 3e to the 3t over 8t. So the second derivative is bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared over dx dt. 8t. So we're going to evaluate this when t is equal to 1. It says 72e to the third minus 24e to the third over 512. So that's going to be 48 e to the third over 512. Particle moves along the curve for t greater than 0 if dy dt is equal to negative 10 when y equals 2. What is the value of dx dt at this time? So first times the derivative of the second with respect to t plus the second times the derivative of the first with respect to t equals 0. So do we know x? No, we know y. We don't know x. So x times 4 is equal to 20. X is equal to 5. So we have 5 times 2 times 2. dy dt is negative 10 plus y is 4 dx dt. It's equal to 0. So, whoop, that was weird. 4 dx dt is equal to, let's go with 20 times negative 10, 200. So dx dt is equal to 50. Particle moved along a curve that the position is given by that for t greater than or equal to 0. Write an expression that represents the distance between the two x-intercepts, but do not evaluate. So we're going to find the expression. We're not going to evaluate x-intercepts. Well, that's where x is equal to 0. X-intercepts, that's where y is 0, excuse me. 0 is equal to t squared minus 7t plus 10. So that's t minus 2 and t minus 5. So from t equals 2 to t equals 5. Now we need, well, we can probably just do this. We can go integral from 2 to 5, square root of the derivative of x squared. Well, the derivative of x is 8t minus 3, and we'll square that. And then 2t minus 7, and we'll square that, dt. If x and y equals those, find the t values where tangents to the curve are vertical and horizontal. So dy dx is equal to, the derivative of y is t squared minus 6t plus 8. And then we have 6t minus 12. So find the t values where the tangents to the curve are vertical and horizontal. So horizontal, that factors into t minus 2 and t minus 4. So t equals 2, t equals 4. And vertical, we got 0 is equal to 6t minus 12. So 6t equals 12. And so t is equal to 2. Find the length of the curve on the circle. X equals 5 cosine, y equals 5 sine. From t equals 0 to t equals pi over 2. So we're going to do the integral from 0 to pi over 2 of the square root of, well, the derivative of x is negative 5 sine of t, and the derivative of y is 5 cosine of t. So we're going to go 25 sine squared t plus 25 cosine squared t dt. Well, if we factor out a 25, Factor out of 25. We get sine squared t plus cosine squared t. So now we're doing 0 to pi over 2 of the square root of 25 dt. Well, that's 5t from 0 to pi over 2. So that's 5 pi over 2 minus 0. So it's 5 pi over 2. Particle is moving along a curve with v of t as those. At time t equals 3, the particle is at the point 46. Write an equation for the tangent line to the curve when t is equal to 2. So we need a slope. dy dx is equal to 4t squared minus 3t over 3 sine of 4t squared. We're evaluating that when t is equal to 2. So that's equal to, let's go with 4 times 4 is 16 minus 6 over 3 sine of 16, whatever that is. Well, it's actually a negative 11.577. So that gives us the slope, but now we need the point. And since we're backing up, x is going to be equal to 4 and then minus the integral from 2 to 3 of 3 sine of 4t squared dt. And that ends up being, after you use a calculator, it is 4.163. And the y coordinate is, now we're backing up, 6 minus integral from 2 to 3 of 4t squared minus 3t. And that value is, let's see, negative 11.833. So the equation is y plus 11.833 equals negative 11.577 times x minus 4.163. Find the speed of the particle when t is equal to 2. Well, that's the magnitude of the velocity vector. So that's square root of 3 sine squared of, let's see, 4 to 16 plus, now it's 16 minus 6 plus 10. But that's squared plus 100. Let's go 10 squared. And that's equal to 10.037. Find the position of the particle when t is equal to 1. All right, so we did something similar in that we're backing up. So we have 4 minus integral from 1 to 3 of 3 sine of 4t squared dt. That's the x, and the y is 6 minus 1 to 3 of 4t squared minus 3t dt. And when you throw that into a calculator, you get 4.249 comma negative 16.666. At time t equals 2, the particle's position is 3, 4. It is known that we have two derivatives here. Is the horizontal movement of the particle up or down at t equals 2? Explain your reasoning. Explain your answer. Find the slope of the path of the particle at time t equals 2. So dy dt, can we get that to, oh, there we go. Dy dt evaluated when t is equal to 2 is equal to the tangent of 2, which is negative 2.185. Now that's less than 0, so we're looking at down. Find the slope of the path. Dy dx is equal to tangent of 2 over square root of 2 over e squared. And that's equal to negative 11.416. Find the x coordinate of the particle's position at time t equals 4. What do we know? We know that at 2, the x position is 3, and we're going to 4. So integral from 2 to 4 of square root of t over e to the t dt. and that is 3.190. Find the speed of the particle at time t equals 4. Find the acceleration vector of the particle at time t equals 4. So find the speed. That is going to be the magnitude of the velocity vector. So when is it? 4? So 2 over e to the 4th squared plus tangent squared of 4. And that is equal to 1.158. 1.158. Find the acceleration vector. So we need the derivative of, well, we'll just do derivative in our calculator of square root of t over e to the t, and we'll plug in t equals 4. And then we'll take the derivative of the y of tangent of t, evaluate that with t equals 4. And the decimal values end up being 0.036 and 1.157. Find the distance traveled by the particle from time t equals 2 to t equals 4. Set up but do not evaluate. Find the distance traveled. Distance traveled would be, integral from 2 to 4, square root of t over e to the 2t, that's squaring that, plus tangent squared of t dt. Particle moves in the xy plane such that x of t and y of t are those. Find the speed of the particle when t is equal to 2. So the speed is the magnitude of the velocity vector. So that's square root of, we need the derivative. X prime of t is equal to 2 times pi over 2 is pi. And then we got negative sine of pi over 2t. So it's going to be pi squared sine squared of pi over 2t plus, and here we have 3 pi over 2 cosine of pi over 2t. So 9 pi squared over 4 cosine squared of pi over 2t. And that's, now we need to plug 2 into that, which is square root of pi squared. See, 2 sine of pi is 0. So that piece goes to 0 times 0. And then let's go cosine of pi is -1, but we're squaring that, so that's 1. So 9 pi squared over 4, but times 1. So we have 3 pi over 2 when we square root all that. Find the acceleration vector when t is equal to 2. Acceleration vector. All right, well, we need the derivative of those. So we need, let's go with, it's going to be negative pi squared over 2 cosine of pi over 2t. And let's go with 3 pi squared over 4 negative sine of pi over 2t. We're going to evaluate that when t is equal to 2. So cosine of pi is -1. So that's going to be pi squared over 2. And sine of pi is 0. So that's going to be 0. Find the Cartesian equation for the path of the particle. Find the Cartesian equation for the path of the particle. I'm going to do letter C up here where I can see the equations. And the pi over 2t and pi over 2t, that's the same. So it's going to be x squared over 4 plus y squared over 9 is equal to 1. Here we have the natural log. Well, let's do this. Let f of x equal this function, this expression, 1 plus 2 e to the x to the 1 over x. And if we plug infinity to that, we have infinity to the 0. So we have limit as x approaches infinity of natural log of f of x is equal to the limit as x approaches infinity of 1 plus 2e to the x to the 1 over x, natural log. So now we have limit as x approaches infinity of natural log 1 plus 2e to the x over x. Now we can do L'Hopital's. Limit as x approaches infinity of 1 over 1 plus 2e to the x times 2e to the x. And it's over 1. But, as we go to infinity, this 1 becomes very insignificant. So this ends up being 1, and we have e to the first. Here we have the limit as a approaches infinity, integral from 2 to a, of x to the negative 4 dx. When we add 1, we get x to the negative 3 times negative 1/3. So we have the limit as a approaches infinity of negative 1 over 3x to the third from 2 to a. So limit as a approaches infinity, negative 1 over 3a to the third plus 1 over 3 times 8, 24. So we have 1 over 24.